Hello, this is another in my series of videos reviewing a dataset of underwater images that was collected for the purpose of making a 3D model of coral reef landscapes. If you haven't seen one of my videos like this before, the idea is that collecting good data is 90% or more of the challenge in making photogrammetric models of underwater sites. And although this is absolutely something that any skilled diver could do, there are some common pitfalls I see regularly, and I want to share examples of these obstacles as I come across them, so that we all might learn something and hopefully save time and collect better data in the future. In this case, I have a data set collected over an area of about 10 by 10 meters at a depth of a few meters. There were two cameras used, both with images of this same plot on the same day. I'm not sure if they were collected at exactly the same time, but it looks to me like they were not. I always like to start by looking at thumbnails of the images themselves. One of the cameras was a Sony Alpha 6400. Let's look at this one first. There were 779 images in this set. Right away we can see that there's relatively consistent exposure among these images, no very bright or dark ones, and that's good. Although even at this coarse scale you can track features across multiple images, like this red dot here you can see in a bunch of frames. If we open this up and zoom in, you can see it's a mesh bag over a dive weight. This image is in focus, it's not blurry. All of this is really good. Scrolling further along, we can see that there is at least one scale bar in this dataset, and clicking here, you can see that this is included on multiple frames. It's also in focus. All of this is great, and I'll make a point here to point out that there is an annotation on this scale bar so that we know how big it is. In case the data sheet is lost or whatever. Scale could still be recreated from these images alone, and that is great. Highly recommended. At the end of this set of images, there are a number of oblique shots. Most of the images are from nadir view, but these ones at the end are oblique, taken at an angle to the seabed. It's generally a good idea to include images like this, but this is too much. When you start seeing water column in the background, that's too much. Too steep of an angle. It's better to keep it so that the seabed is entirely sharp and in focus across the entire scene. More like this one here, but even this is kind of marginal. So I deleted all of these oblique ones when processing the data, which we'll see in just a few seconds. Finally, I took a look at the EXIF data for these, and you can see they were all at a fixed shutter speed, 1/1250th of a second, which is plenty fast, and at aperture of f3.5. The ISO varied to accommodate changing lighting from frame to frame, which is fine. I would probably drop the shutter speed a little bit to something more like 1/800 or 1/640th, and use a smaller aperture, more like f6 or f8, something like that, in order to increase the depth of field. Remember, the key is just to have no blurry images, and that's not a problem here in this case because there seems to be plenty of light. The GoPro images were all shot in still or interval timer mode, and I won't say much more about these. They seem fine. Basically, everything I just said above about the Sony images apply here as well. So I loaded these datasets into Agisoft Metashape and I aligned them separately. They both worked well in the sense that all of the images matched, 517 of 517 for the GoPros and 679 out of 679 for the Sony. This is consistent with what we saw before of having sharp images with good image-to-image overlap. Looking at the GoPro images, or the data set from the GoPro images first, they kind of appear to line up okay. There's no holes or anything like that. But the problem here is with the swimming pattern. If I turn on the cameras, you can see that this is only about 5 passes and all in one direction. This is not good from a coverage or geometric fidelity standpoint. If you look at the data from the Sony images, this problem becomes more apparent. You can see big gaps here between transects that should be filled by a set of passes in the second direction, or by more passes in the first direction. Looks like there were about 8 passes one way here and maybe 4 in the other direction. For a 10 by 10 area, I would ideally like to see about 10 passes in each direction or thereabouts. Here's an example of how that looks. This site is just barely 10 by 10 meters, and you can see there are about 12 passes in each direction, plus a swim around the entire border, plus a diagonal pass across the middle. There were about 1,100 images here from each of 2 cameras, so 2,200 total went into making this model. So in conclusion, this example that we're looking at here falls into the incomplete dataset category. There are good images, a nice swimming speed, and a nice height off the bottom, but just not a complete coverage of the area. The final thing I'd say here is that I can see just one of those scale bars, but I think just one. It's better to have more like 4 or 6 of these for an area this size. The others might be there and just not visible because of the missing data, but if there's only one, then I would suggest adding more. In conclusion, I'd like to acknowledge support for this series of videos from the Pew Fellows Program in Marine Conservation at the Pew Charitable Trust. And that's it for this review. I hope this helps you collect better data for your project.